All right, what's going on? I wanted to show off a Toyota pump controller. This pump controller is part number 89570-48010. I find it frequently used on a lot of Subarus, a lot of Nissans, and a lot of Toyotas, which gives me confidence that it does a pretty good job at what it's supposed to do. And I expected it to be unified across the board for most of them. So that's kind of what I'm checking right now. I'm just kind of checking the scope operation. So I found that the operation that it works in the window that it works in, and I'm going to talk about that a little bit. For my output wiring, it looks for the high side state for control. It also, I haven't checked it on a 5-volt reference. I will in a few, but as of right now, I try to set it up on a stepper motor or a drive-by-wire output. I've validated those to be operational. So currently the output table, the only premise is you want to stay out of the range between, like, let's say 76 and like 86%. You want to step away from those, or 76 to 89% perhaps. I haven't figured out exactly. There's a situation where it'll go into basically a fail-safe mode where it won't step up or down or increment or decrement its values. And you don't want that when you're trying to actively control something, right? So currently it's at 0. On the right side here, we have the Pico scope running. The Pico scope shows 0 volts because we have our output at 0%. I'm going to take this output and we're going to go to essentially the starting point. It has a little bit of a hysteresis, but we're going to start at 20%. So you can see that it steps up to, roughly between, it's like 3233 volts, right? I have it running on a 14-volt reference system right now. And I don't know if you can tell it's spinning. I'll go back to 0. And you can maybe see that it stops, and we'll go back to 20, 0. And you can see it starts spinning again. So, it correlates with the actual controls we're seeing from the Pico scope, right? The value between 20 and like 76 is infinitely capable. So I'm just going to step through it. So you can see it's incrementing over here on the right side and just keeps incrementing all the way. And we'll take it over to about 75. And at 75, let's see what we got for voltage here. Well, basically 12-ish volts, just under 12 volts. So, what'll happen is if I go into like the 80 to 89 range, it ends up sticking there. And when you try to decrement it past any value, it just won't go back down. So if I go back down, you can see that it's stepping down. But if I go back up and let's say we hit 80, right? And then I go up to, see now it's stuck at whatever value it is there. Basically stuck at just under 11, just under 12 volts. So the only way I can fix that is by getting it back to 0. Also, 100% doesn't work, so you can't just send it live a total feed. It does require PWM to actively control it. But if I send it 95, well, let's go back to 0. Send it 0, then we'll send 95. You'll see it goes to full tilt. And then if I go back to 75, it steps it down, and we can step through those standards all the way down to roughly 15, which drops down to 0. So I say step it, 20 to 75 and 95. That window works. And then, basically 0, 20 to 75, 95. Frequency output should be 75 hertz. And that is about it. So I hope this helps explain it. It also is analog voltages, not sending it some 10 to 14 kilohertz PWM output based on getting a PWM input either. It is rock solid. So, yep. We'll see you in the next video. Hopefully this part can bring some ability for better pump control, especially if you're running an oversized pump. The rated current, my understanding, is 25 amps. So you may need to bear that in mind. But if you're running multiple pump systems and want to control the load to multiple pump systems without running PWM control and just lowering the actual pump voltage, this is a good step down solution. But anyways, we'll see you in the next video. Y'all have a good one.